Okay, quantum computing. So now we have 168, and I'll start bombarding you, but uh, be prepared to be, if you like, challenged in terms of thoughts and mind and how you think about things. Just let me have a quick show of hand. I will only see, obviously, 48 on the screen, but how many are fairly, at least familiar with not heard of quantum computing? Hopefully, you're all heard of it, but has some level of familiarity. Can I have a show of hand? How many? It helps me. Okay, I see some, not many, huh? Okay, good. We have a percentage, probably less than 5% anyway, from what I can see on my screen. So, what is it about quantum computing that seems to be a little bit, no matter how much you dig into it, it still leaves you asking questions. So, there is here, this says you need to understand how a quantum computer works, but you won't. That's a bit of a challenge for all of us, if that is. And I don't know if those who raised their hands said they're familiar, if they really feel they understand how it works, and maybe this is a bit of an overcomplication. It's not really that complicated. Amit, you raised your hand. What do you think? Is this statement right, wrong, or in between?
Oh, hello, good morning, Mike. I think this is very right. We are still learning about quantum computing, and on a very high level, what we can say that the traditional computer works on binaries, which is 0 and 1, while
No need to get into how it works.
yeah,
Just comment on this statement.
yeah, this comment is absolutely right.
Uh, Zach, you raised your hand. What do you think? Is this an exaggeration or is it true statement?
Yeah, it's true. I don't know how they work.
All right. So let's see if we can. Actually, quantum computers or quantum mechanics, it was Richard Feynman, the famous physicist, said if you think you understand quantum mechanics, then you don't. I don't know if that statement makes any sense to you. To bring it home to you, let me ask you a question. And this question is for the men. I might ask it of the women in a minute. If you think you understand women, then you don't. If I say that to you, if you think you understand women, then you don't. Who would care to comment on that statement? I see Tawfiq is smiling. I don't know. Tawfiq, are you married?
Yeah, that's why I was smiling because I want, as much as I'm smart, I can't be smarter than her.
Okay.
Maybe the ladies can comment better than the men.
Yeah, let's finish the men. Let's see if they. You see, at source, we come at it with a certain brain, body, emotion, background, history, evolution. And whenever you look through your own glasses, you will see things in a certain way. The worst thing that can happen is you think you know it. It's when you admit to yourself, I can't understand women, you're probably better prepared than the person who thinks I do. And I would ask now, women, do you understand men? Fortunately, most women I talk to, they say, I don't understand men. Like they're always starting wars. They're always having silly games that they play. Does any woman on the call and feel that she understand men? Naveen, what do you think?
Yeah, they are too simple. They are three standards kind of lands that, or they are too simple. Sometimes they are too simple that they complicated, but they are three standards. Like not like women. We have our emotions and we have our thinking, and so women, I feel they are too simple to understand.
Okay.
Especially if they are husband.
Okay, so Naveen has a level of understanding and she stereotyped them as too simple. That may be the case, or maybe it's just an opinion that has been ingrained over the year. And actually, men are quite sophisticated, but in a different dimension. So that's what I'm trying to say. If you think you understand, you actually probably don't. You've got an idea. So let's dig a little bit deeper and see what is the story and what is it that makes it hard to understand. Sometimes it takes us time to understand concept. And now you talk about them like it is bread and butter. You know them. For instance, for those of you old enough amongst us, when you first heard of the internet or the World Wide Web, it was like, what is internet? It's just a vague idea, a bit confusing, but it seems to be used by a lot of people, so that it has value. Or cyberspace. I must admit, when I first heard of cyberspace, it was such an exotic notion. Something, is it in space? What is cyber? Now we talk about it like, I'm going to my bedroom. I know what that is. But if you were forced to define what do you mean by cyberspace, the familiarity makes you think you know it, but the reality is just a concept. What about cloud? I must admit, when we first got into cloud computing, I was asked to give a talk or an interview about cloud computing. I didn't even know where to begin to translate it into Arabic because it was an Arabic channel. Cloud, we're now used to it. Everything is so simple, cloud. Half of our business is cloud. So the first thing I want to say to you and today is please relax, have your coffee close to you. I see some of you enjoying your coffee, and open your mind. Hopefully you will get the essence of what I'm trying to say rather than the mechanics. So you need to stretch your mind, and I'm going to give you at the end an example that hopefully will do that for you. So, as a human being, we evolved to understand with the senses. Okay, so our sense of sight, smell, touch, all of these things. And to survive, those had to work in a certain way. Now, if you think you've got it covered, your senses tells you everything. Imagine if your senses was to stretch to a different level. Let me show you one level. We all know, hopefully, that a dog has a much, much more stronger, keener sense of smell. They smell up to 6 times better than a human being. They can discern up to 1 million different smells, while we are nowhere near. We can barely distinguish between maybe the smell of onion and garlic or something like that, even though that's so obvious. So imagine having that kind of a smell. Or what about a bat that can hear 10 times more than we hear? Or an eagle. It's like having binoculars in your eyes. Now, what do you think? You think it'll be a blessing or a curse to have these things? You think it's an advantage or a disadvantage? I need participation. Don't let it be just a one way. Please help me. And if you spoke as much as you really appreciate, let the others pick up some courage and speak. I don't want it to be just one or two people dominating the interaction.
We'll overload our brain.
We'll overload our brain. Right. Amr, you seem to be ready to talk. Dubai.
Yes, it is. Yeah, I think it is a curse because I think if we have beyond our senses, maybe it will be too much data to absorb and maybe make our life miserable.
Absolutely. Can you imagine going into the lift and can smell like the strength of a smell of a dog? You'll die to get out of the lift. Some people, there'll be about 100 smells, most of them, because us human beings have opinions. I like this, I don't like that. The dog doesn't mind that we mind. We don't want too much smell. We don't want to see too much. We don't want to hear too much. We already complain about the noise. So, but that tells you our world is very narrow and it is there sufficient for our survival, for our evolution. And that's the first thing to remember about quantum computing. It is beyond what we evolved to sense. And that's the first thing about the difficulty with that. Plus, our brain resists anything that abnormal. I'll show you this picture and see how you react to it. Can you see? Can you see the internal resistance you feel? This is not normal for me to see front of the chest and back of the head. And a lot of what you will experience with quantum computer is almost like that. So why are they hard to understand? So now we're going to go into the guts of what is it about quantum computers that makes them hard to understand. You've all probably seen this imagery of what they look like. Nothing like a CPU of a traditional computer. Does anybody know what's all this complicated spaghetti junctions doing? Who is, some of you must have come across that. So I know some are resisting to talk if you've talked before, but if it goes too quiet, I still want anybody to say something. What about Natarajan? You're the one into all these things. Where are you, Natarajan?
Morning, guys. I'm there. Yeah.
Okay. Does that image tell you anything?
So it is a kind of data flow. There are a lot of processing happens in a logical way. So I would say it is like a GPU of large scale, just for easy understanding.
So it's like a micro, like a micro station.
No, wait a second, so that I don't let you, if you like, put yourself in a corner. If you don't actually know, it's not something that we can guess at. All that you're looking at is the cooling, because for quantum computer, they need to operate at minus 273 centigrade. We're talking about the absolute zero. To do that, all these pipes are cooling to bring it down to that temperature. Actually, the processing happens in a unit down here. It's a tiny thing where what is called the qubit circuitry is sitting. All of that is just cooling. And frankly, that's why today quantum computers are still difficult to implement on a large scale or commercially. Because where would you get all this apparatus installed, cooling, etc.? And we will come to see why we need so much cooling. So first of all, superposition. Here we go with now terminology that almost like the smell of a dog. He can smell a lot of things. Superposition, nobody, I'm sure, in this audience, including myself, is familiar with what is this? Superposition? And basically, in quantum computing, means that can be in two states at the same time. So we're familiar, a bit in traditional computers can be 1 or 0, right? But we don't know if there is a chance for that bit to be both 1 and 0 at the same time. That is just unreal to us. Is it 1 or is it 0? No, it is both. That's superposition. And they perform at their best when they stay in superposition. And to stay stable in superposition, they need to be at absolute 0. The moment they go higher temperature, that twin state collapses to either 1 or 0. Once it collapses to 1 or 0, it is like a traditional computer, not much more powerful. So that's the first thing that you will not see in nature normally. Something is both this and that at the same time. And yet, that's an advantage that scientists can take advantage of. Second, entanglement. Some of you would have heard the term, but this is one of the most sort of, I don't know what you call it, strange phenomena that two, if you like, photons. If they're entangled, one can be on this side of the galaxy and the other could be on the other side of the galaxy, never mind the Earth. And if one of them behave in a certain way, the other one will behave in the, one is spin up, the other one will be spin down. If you turn it to spin down, the other one will turn to spin up. And you think, how did they communicate? It's very strange. We always think they need to be at least within light speed distance of each other to talk. But no, they could be on one in here, one on the sun. And they are entangled, means their behavior mirrored in one or the other. I hope I'm not beginning to lose some of you, but trust me, at the end, it'll be worthwhile. But maybe as we're trying to bring in this concept, it may be a bit strange. If you stay with it, at some point, it will become like internet and cyberspace and cloud. You start talking about entanglement and superposition like they are, past the sugar, because we're familiar with them. Today, what is he talking about? Why is he wasting our time talking about something so esoteric? Supercomputer or quantum computer, it's all about probabilities. We don't deal. We deal in certainty. Are you going or you're not going? Probability is not comfortable for us. So all of these things are in the nature of quantum computers. So most of it doesn't make sense, but we don't care if something makes sense. We only care, can we use it? Is there a benefit in that? And we can, and they have proved it, that it can perform certain functions 100,000, a million times faster than a traditional computer. I said certain functions, not everything, and I'll come to that. So let's just quickly see the difference between a bit and a qubit. So all of you think you are, but I hope you are. A bit is either 0 or 1. Actually, we think of bit and 0 and 1. It's nothing like that. It's a voltage. It's either 0 or 5 volt. But we got used to it, 0 and 1. A qubit is 0 and 1, but actually both 0 and 1 at the same time. You think that's not possible. Now let me show you an image which is not true, but nearest you'll get to understanding what does it mean to be both at the same time. If I spin a coin in the air, is it head or tail? Come on, somebody. Giant, you are usually quite happy to talk. Where are you?
Good morning, sir. Right here, sir. Yeah, so when you actually toss the coin, it is flipping and it is considering both the options together. So even if you might think of one option, but you can get any of the options at the end of it.
And only when it lands and then it collapses into either head or tail. In midair, it's both. And that's not so far off a qubit. A qubit is in two states at the same time. At some point, it collapses to one. But when it collapses, it is no longer, if you like, a quantum value. And ideally, you're pooling the whole system to make sure it doesn't collapse. Entanglement is really very useful. If you can have qubits entangled, i.e. affecting each other's, it's extremely helpful in quantum computing. In fact, it is strange and yet very useful. Einstein hated it and called it spooky action at a distance. He could not buy into things affecting each other when one in maybe New York or one is in Abu Dhabi instantly. It's not at the speed of light. It is instantly. So something beyond our thinking, beyond speed of light, that is making two things entangled and behave in tandem regardless of distance. So let me now give you an example so you can see, and this will not make it any easier, but I am getting you familiar with the purpose that at some point you're going to think, I'll let this idea marinate in my head, and someday it will become familiar. So in a traditional computer, you're trying to guess, let's say, a password, and the password is 4 digits. A traditional computer will try every single combination, right, to find the correct password. 1, 2, 3, 4. So what's that? 4 by 4, 16 attempts. Eventually, it will find something. That's why if it is password gets bigger, you use different characters, etc., it can take 1,000 years because it has to try every combination. Okay? So you put them one at a time, eventually, aha, I found it. Now watch what happens with a quantum computer. So it will, quantum computer we said is 0 and 1, but at the same time. So when you have this challenge of 14, quantum computer doesn't go trying anything like that. It goes and attacks all possibilities at the same time. Can try 16 possibilities in parallel. That's why it can be so much faster. It doesn't go, no, it's not this one. No, it's not this one. It will go for them, bam, all together and sticks them in, then faces a problem. It's got the answer, but it's also got some wrong answer, and it's all jumbled together. So how do I discern the right answer from the wrong answer? This is where, frankly, human ingenuity, some scientist called Grover came up with an algorithm, because the right answer gives a hint in terms of the amplitude of the reaction. When you put them in, one of the reaction in the machine is, let's say, more positive than the others. We don't know, but you need a mechanism to filter it out, and that is called the Grover algorithm. Don't look at the equation, don't bother about it. It is just somebody found a way, and it sweeps away all the values of low amplitude. And so we have one that gives like hands up, and everybody else is hands down. And the Grover algorithm managed to sweep all the hands down and ends up with the right answer. But for that to happen, like we said, those qubits mustn't collapse, so you need the cooling all the time. I can see some of you rubbing their, forehead. What is he talking about? I don't think I'm any wiser, but you won't get it on first pass. You will get used to it more than get it. Remember that. Like you got used to cyberspace, you didn't get cyberspace. You will get used to cloud. I bet most of you still don't know exactly what's in the cloud. Where is this cloud? I remember taking my wife to the cloud site, cloud computer site. Murgesh, you went with us. What was it called? The Equinox or something? No, you're muted.
Equinix, Equinix.
So that's when my wife, Jenny, says, this is the cloud? I said, that's what we think of the cloud, but physically there is something, is the cages and everything sits in the site. That gives you a physical thing, but actually it's not like that. The cloud is dispersed all over the earth, interconnected, some data center here and there, and they're all connected. But we talk about it like, my cooker is a bit dirty and I understand it, but we don't understand the cloud. How is it structured? Why it works the way it works? Okay, so we have a Grover operator, we get a right answer. Now we think, how can I use this? Because anything that needs sequential examination is not suitable for a quantum computer. Anything that needs parallel, that you can try everything in one go, that's where they'll excel. So let's take this new approach. If you had a maze, a quantum computer will try every possibility the traditional computer will try every possibility. There could be 1,000, and eventually it tells you the right answer. Quantum computer, since it is 0 and 1 and all the states between, can try them all in one go. So in an instant comes one of the answers, give higher reaction, and Grover operator sweeps away the rest. You know the answer. I don't know if some of you getting the idea. I am sure getting maybe a feel. Eventually, it will be a real idea. What about optimization problem? Trying to find the quickest route from A to B. Let's say whether it's a Google map or some call it the salesman problem, where you're trying to find the most efficient route to visit all your clients. One by one, this can take, especially if in a very complex terrain, can take a long time. Quantum computer goes back, all of them one go, and you get your answer. Drug discovery, the options and possibilities is infinite. Traditional computer can take days, years, maybe millennia to solve. Quantum computer can go bang, all possibilities at once. So hopefully you got some feel that says a man's mind is stretched by a new idea or essentially never shrinks back. If I succeed in anything this morning is to see, can we stretch our brain beyond the norm? And I guarantee you, after I finish, your brain cannot go back to where it was. You may not like that. Maybe you'd rather go back to your familiar brain, but it's not possible. You will be exposed. You have been exposed, and I will share a bit more just to expose you finally to some idea that after that, it will stick in your mind. This is a lady looking at her baby, right? I'm going to tell you a story, and in this story, it is going to introduce an idea, and you will see that after I finish telling the story, you cannot forget about it. And the story has value. When a woman looks at a baby, usually women, and correct me if I'm wrong, will carry the baby in their left arms or the non-dominant. If you're anyway born right-handed, you might do it differently. But let's say left-handed. So they carry in the left arm because they want to keep the right one free for cooking, for cleaning. They're going around the house with the right arm free. Left arm is carrying the baby. If you carry the baby that way, notice what's happening. Her left eye is looking at the left eye of the baby. Usually the baby's right eye even can be stuck in the sleeve of the mother. What does that do? If a baby and a mother both connect, develop trust, affinity by looking at each other's left eye. And that's a fact that has been explored by science, psychology, etc. And if that is true, can I use that? And all of you would like to have better relationships, better trust. And what is more bonding and more trustful than a mother and a baby? So I'm going to ask you going forward, when you visit somebody and you want to gain their trust, you want to create better affinity, focus on looking at their left eye. That may seem strange, but that is backed up by science. Look at the left eye. You will find they will also naturally do that once you're looking at their left eyes, and trust will build differently. Relationship will build differently. So whether it is business or relationship, actually it's a power you can use and is subconscious to the other party. But you can develop a better relationship knowing that. I hope you try it and see what you feel about it in the next week or so. So let me conclude by saying you either have a locked mind that says, forget this, all this, hocus pocus stuff, I don't get it, or you're willing to open your mind and stretch it. And if you are, hopefully today is your first step on stretching your mind, at least in the direction of quantum computers, but even about this feeding woman, maybe that will also help you with your relationship and in business. Thank you very much. And I would appreciate it if you rate and leave comments. Thank you.